How do temperature scales relate to thermal equilibrium? Imagine trying to compare how hot or cold different objects are without a common language. That's where temperature scales come in. They give us a way to measure and talk about temperature clearly. But how do these scales connect to the idea of thermal equilibrium? Let's find out. Temperature scales like Celsius, Fahrenheit, and Kelvin help us assign numbers to how hot or cold something is. These numbers are based on specific points, like the freezing and boiling points of water for Celsius and Fahrenheit, or absolute zero for Kelvin. Absolute zero is the lowest possible temperature, where molecules stop moving. It is the starting point of the Kelvin scale. Thermal equilibrium is when two objects in contact reach the same temperature and no heat flows between them. Think of two cups of coffee at different temperatures. When they sit together, heat moves from the hotter to the cooler cup until both are the same temperature. That's thermal equilibrium. The connection between temperature scales and thermal equilibrium is built on the idea that temperature is a property that indicates how much heat a system has. When two systems are in thermal contact, heat flows from the system with higher temperature to the one with lower temperature. This process continues until both systems share the same temperature. The Zeroth law of thermodynamics states that if one system is in thermal equilibrium with a second system, and that second system is in thermal equilibrium with a third, then the first and third systems are also in thermal equilibrium. This law makes temperature a measurable and consistent property. Thermometers work by coming into thermal equilibrium with the object they measure. When a thermometer reaches the same temperature as the object, the thermometer's reading on a specific temperature scale shows the temperature of that object. For example, a mercury thermometer in a glass tube will stabilize at a level that indicates the temperature in Celsius, Fahrenheit, or Kelvin. So, the reason temperature scales are meaningful is because they are based on the principle that systems in thermal equilibrium share the same temperature. Without this idea, measuring temperature would be meaningless. The scales give us a universal way to compare and communicate how hot or cold something is, based on the property that reaches equilibrium. In essence, temperature scales are a way to quantify the property that defines thermal equilibrium. They turn the concept of heat flow and molecular motion into numbers we can use every day. When two objects reach the same temperature, they are in thermal equilibrium, and that shared temperature can be expressed on any of these scales. This is how temperature scales relate directly to the fundamental idea of thermal equilibrium.